So the first topic, whatever you're going to cover, is about the 8D problem solving tool. And then the second topic, what we'll be covering is about FMEA, that is the failure mode effect analysis. So the learning outcome, the course content, what we are going to cover in 8D problem solving is first about the introduction to 8D. So what is the 8D and what we are actually trying to do. Then there are actually 8 steps in this particular problem solving tool. And we are going to learn about these 8 steps. That is how, whenever you are finding that a problem is there in a process problem is there, then how we are appointing a problem solving team in order to solve the problem. Then how we describe the problem description, and then containment and short-term corrective action. So what are the actions we are going to immediately take in order to ensure that the product is usable immediately? That is the containment. Then root cause analysis. So we have to find out what are the root causes of the problem. Then based on the analysis, then the long-term corrective actions. Then once we decide that, then we have to implement it and verify. And then after we are checking that the corrective action is effective, then you have to go for a preventive action. And then finally, we have to close it and congratulate the team and conclude. So these are the 8 steps. So we are going to learn about that one by one.
So it's basically related with only manufacturing sector, or just I'm been working as an in medical background.
Okay.
So it's a pure IT. So the same technique is being used to resolve.
So yeah, mainly this particular tool is mainly used for whenever you are having some issues in your product or service. Okay. So either at the in process or at the final stage, or even sometimes you are getting some customer complaints. Okay. So whenever you are finding that there are some issues with the product or service, so it is applicable for service related industries also. So for example, you are so you are getting a complaint from your customer that you are not meeting your SLA with respect to some email response or something like that. Then you can just solve that particular problem by using this AT report. Okay. Thank you. So this is actually a problem solving tool. So mainly you can say that it is used for in many of the big companies, like whenever, suppose if you are supplying to big companies like Maruti or Amazon or any other bigger companies, and whenever they have some rising, then some customer complaints, then they will be expecting some sort of a systematic approach for analyzing what is the problem and then taking a permanent corrective action so that the problem does not recur. So in that way, they will be asking for this AT report. So mainly used. Okay, so thank you. Yeah. To address customer complaints and in process non-conformance, you can say. So your product is supposed to meet a particular specification, but you are finding that some problem is there. Then in that case, then you'll be able to use this 8D report. So basically, it is actually there are 2 basic requirements for solving a particular problem through this 8D report. The first one is actually whether you are aware about the root causes of the problem, right? Root causes are known. So if the root causes are known, maybe it is not necessary for you to really go through this 8D report, because you know the root causes, so you take action and then you can just solve the problem. But in many cases, you may find that you are unable to find out the root cause of the problem. So it will take a bit of time, because sometimes the problem root cause of the problem cannot be identified immediately. It needs a structured systematic way of analyzing. So in that case, you cannot wait for the permanent action to be taken, because it is going to take some time. So you need to really take some quick action so that immediately you will get some solution for the solving the problem. And then you will have time to analyze the root cause of the problem, and then you take the corrective and preventive action. So normally this is used whenever the root causes are not known, and then it is going to take some time. Then you will be using this as a sort of an intermediate step. And then Second, this thing is when you need a systematic documentation of the issues. So that means this AT report we are I'm just going to, again, I think this presentation itself is having some templates so that all the problems, whatever the problem description, whatever the immediate action you are taking, whatever the root cause analysis, how you are doing. So all those things are captured in this particular format so that again, you can send it to the customer or you can just send it to the relevant department. And then finally, like on a long-term basis, this particular knowledge will be available within the organization. So whenever you are finding that some non-conforming products are produced either in your own organization, or whenever you are receiving a complaint from the customer saying that something is not really meeting the specification, some problems are there. So in that case, you can use this method, that is the AT report. Standard template will be there. So you'll be filling in all the template and then sending it to the customer. So normally big customers, they will be expecting the AT report. And then once you do the analysis and then solve the problem and then the effectiveness of the problem, everything is addressed, then they will formally close the particular complaint. So this is the background for using a AT report.
D stands for?
I'm just coming to that. So this is actually a 8 discipline approach. D stands for discipline. So again, that is coming in the next slide. So we will just start with, yeah.
This is a brainstorming concept or not?
This is
a brainstorming concept.
What is that concept?
Brainstorming concept.
Yeah, brainstorming. Yeah. So we will be doing a lot of brainstorming. Yeah. Okay. So let us start with the definition of what is a problem. So a problem is an obstacle which makes it difficult to achieve a desired goal, objective, or purpose. So for example, we are I'm just taking a very simple example. So we are supplying a 10 millimeter rod to a customer. And then he is giving a specification that the diameter of the rod should be from 9.10 plus minus 0.5. That means he is willing to accept from 9.5 to 10.5. So on a particular batch, we are spending around sending around 10,000 rods to the customer. And then when he is randomly picking up some samples, then he is finding that some of the samples are out of specification. Maybe he is getting somewhere around 9.4 or 10.6 or something like that. So then he is going to write that as a problem, right? Because it is a problem because it is not meeting the goal. The specification is given, that specification has not been achieved. So that becomes a problem. So whenever we are unable to achieve a goal or specification or objective or purpose, then we call this a problem. And this refers to a situation or a issue that is unresolved. So that means we are facing some issues which is not meeting our expectations or meeting our purpose, and then we need to really go for some solution. So that's what we call as a problem. So when we talk about a solution, whenever we have a problem, then immediately we try to find out a lot of solutions are there. Whenever we do a brainstorming session, then we identify a lot of possible solutions are there. But again, it is not possible or it is not appropriate to implement each and every solution or any solution that is coming to your mind. So again, you need to really brainstorm what are the possible solutions that are possible. Then from those solutions, you should be able to pick up the best possible solution, and then you should be able to implement the solution, right? So for solving the problem, again, you will have to identify the root cause of the problem. So whenever you know the problem, then you try to brainstorm and then find out what are the potential causes for the problem. And then you do again a brainstorming session to find out what are the possible solutions that can be implemented. And then again, you do so you can use some sort of your tools to find out which are the best solution that can be implemented, and then that can be implemented. So after implementing, you just check whether the solutions are effective, right? So that's what we call as a problem solving. So whenever in our typical day-to-day life, we are, you know that we are always facing some problems and we are also solving problems. So this problem solving can be divided into 3 parts. The first one is the reactive, then proactive, and day-to-day. So whenever we talk about a reactive problem solving technique, so that means the problem has already happened and we don't want the problem to happen again. So we are taking some actions. So those actions we call as a reactive approach. So the examples are the 5Y or 80 report. So 80 report, whatever we are talking about now. So this is actually a reactive approach. So that means some problem has already happened, and we are trying to find out the root cause and take some appropriate corrective actions, right? So that's why we call it a reactive approach. That means the problem has already happened, and we are trying to solve that. Proactive approach means, again, the problem has not really happened so far, but again, there is a possibility or there is a risk that the problem may come. So anticipating that risk or anticipating that problem, we are trying to find out some solutions before the problem happens. So that's what we call as a proactive approach. So normally any risk assessment, whatever you're doing, or any standard operating procedure, whatever we are doing, why we are writing a SOP? So that means we don't want the problem to happen. So whoever is doing that particular operation, then if they are going to do the process exactly as given in the SOP, then the problem is not going to happen. So that making an SOP or doing a risk assessment are the examples of the proactive approach for problem solving. So that it will ensure that the problems do not happen at all. The third one is about day to day. So day to day, again, small improvements may happen. So we may find that some problems are there, some small, some defects are coming, or some small issues are coming. So then we do the RCA, means root cause analysis, and PDCA means plan, do, check, act. So this type of small activities we do for small improvement, whatever we are doing, we call it as a day-to-day problem solving. So in our regular life, we'll be work life, we'll be doing any of these problem solving activities. So again, let us now come to the description of what is 8D. So 8D is a short term for 8 disciplines, which are 8 distinct steps of a systematic process for problem solving. So how we are going to system, whenever you are finding that some non-conforming products are produced, either in the process or we are facing some customer complaints about the non-conforming product, then how we are going to solve that. So that is a systematic 8 actions you are going to take. So there's a 8 discipline systematic process of problem solving. So the real origin of this particular tool or a technique is not is not known. Probably we are suspecting that that might have originated from the US military. So there is no formal document saying that, okay, this is the origin of this particular template of the format. But we are suspecting that this might have originated from the US military. And the 8D methodology was first described in a Ford manual in 1987 to address the chronic product and process problem. So the formal documentation, we are able to first find it in 1987 in a Ford manual. So they are talking about this 8D methodology. So this 8D methodology focuses on finding the root cause or origin of the problem and establishing a permanent corrective action. So these are the 2 important points. So first, whenever we are finding that there is a problem, then we try to identify what are the root causes of the problem, and then we try to address it by taking a permanent corrective action. So once you apply the 8D report, 8D format, then what we can expect from this particular process? The first one is about the elimination of the problem. So whatever the problem was there in the process, which was creating that non-conforming product, so that problem will be totally eliminated because we are identifying the root causes and taking permanent corrective action. Then permanent prevention of the problem. So the problem will not occur again because we are going to take some preventive action. So that the problem will not occur again. So even before it is any other product or any other equipment or any other location is going to be affected, then we will have some system or some process in place so that is not going to happen. So prevention of similar problems. So whenever we are addressing one problem, say for example, you are running 8 machines. So we are finding that in one particular machine, a particular type of defect is coming. So then we address it through the 8D format. And then whatever the learnings we are getting, whatever the corrective actions we are implementing, so that can be implemented in the other 7 machines also. So that even though they are currently not producing those defective parts, but again, since we are taking these actions proactively, then we are eliminating the chances of those 7 machines also producing the type of defects at a later part, right? So that means whatever you are learning from one machine, we will be able to implement in the other machine and other processes, so that we'll be able to prevent similar problems in future. Then again, we can expect the overall improvement. So the 8D report does not only help only for solving the problem, but ensuring that we are making some improvement. So if you can see the graph here, maybe in the past the performance was maybe slightly reducing, and then because of the problem, then there was a sudden increase in the problem, right? So our performance, there was a big dip in the process because of that particular problem, and then through the AD report, then we made a systematic analysis of the root causes, and then we took the corrective action. So after that, we found that the performance is now far higher, far better when compared to the past performance. So that is the purpose. So the purpose is not only solving the problem and bringing back to the old performance level, but in order to bring back the process, bring the process to a higher performance level, so that some improvement can be achieved. So it is not only solving the current problem, but ensuring that the performance is also improved. So when we talk about the different 8 steps, so what are the different, it is again, you can say that a sort of a CPOC diagram, what is the input output diagram. So whenever we are finding a problem has been discovered, then we just follow these 8 steps, and then we find that the problem is resolved. So the problem was discovered. After the problem was discovered, we just take these 8 steps, and then after taking the 8 steps, we find that the problem is resolved. So what are the 8 steps? So first one is, so we'll have to form a problem solving team. Maybe we can form a cross-functional team. So whichever team, like for example, maybe some people from production, maintenance, quality, maybe in a support, in a ITS company sort of thing, maybe people from software development, people from operation, people from IT support, people from quality. So a cross-functional team can be formed once a problem is identified, so that the problem can be analyzed and solved. That is the first step. So after that, we will have to clearly define about the problem. So what is the problem we are facing? Then what is the extent of problem? So whether all the 100% of the product or service is bad, or whether only a small portion of it is coming as a problem. So whether the problem is coming continuously, or whether it is like intermediate. So those type of this thing. So quantification of the problem and then explanation of the problem we'll have to do. That is what we call as a problem description. Then once we have done that, then we'll have to go for the containment action. So again, containment action is like containment and short-term corrective action. So that means we cannot, because suppose if it's a problem, a customer is reporting a particular problem, then again his production is also going to be affected if the problem is not going to be solved immediately. So in that case, what needs to be done is we need to really give him some solution, so that he can start using that particular product or service immediately. So his operations cannot be stopped because of this particular problem. So in that case, we'll have to give him some solution. Either we'll have to go there and we'll have to sort out some of the issue, or we'll have to tell him what to do so that he'll be able to make some adjustment, and then he can use that particular product. So that is what we call it the containment. And then once again, for taking the containment action, it is not necessary that we will have to analyze what is the root cause of the problem. So that is like, for example, now you assume that you are working in a factory or in an office, and then suddenly the fire breaks out, right? So as soon as the fire breaks out, then the immediate containment action is maybe you'll have to immediately look for whether any fire extinguishers are there, or any water is there, or sand is there. So you just try to put those materials on the fire, and then try to put out the fire. So that is what is going to be the priority now. So at that point of time, you cannot again spend a lot of time on trying to find out what is the root cause of the problem. What is immediately needed is a containment action. What immediately you can do so that the problem is not going to spread, or the problem is not, we will be able to use the product immediately. So that is the containment action. And then once that action is taken, and then some sort of a normalcy is being restored, then immediately we can move on to the root cause analysis, trying to find out what is the root cause of the problem. And then once you have analyzed the root cause of the problem, once you have found out the root cause of the problem, then we can go for the long-term corrective action. So again, we can find out what are the, again, we can do the brainstorming session and try to find out what are the solutions we can take, so that on a long-term basis, the actions can be taken. Then once we decide upon that, then we implement that corrective action. And then after a month or two, again, we verify so whether the action is very effective so that these particular actions can be continuously followed. Then once it is verified, then we go for preventive actions. So preventive action means we know that there was a problem in this particular machine or this particular process or something like that. And then we have analyzed the root causes, and then we have taken some solution, and then we have found that this is effective. Then we can just see again, just analyze where all this problem can happen, in which other machines or in which other locations the same problem can come. Then we can inform those people accordingly, so that they can also take this action, so that even before those processes or machines or locations are affected by this problem, then they already have a solution in hand, so that the probability of this particular problem happening anywhere else is almost going to be nil. So that's what we call as a preventive action. And once the last step will be to celebrate the success. Okay. So before going into the individual processes, so now what is very important to understand the difference between the three terms. I will write it down here. The first one is the correction. We also call this as a containment. And we also call this as a defect repair. All these are same meaning. The second one is about the corrective action, because I think you are seeing all the three terms in this particular slide. So before we move on to that, then we need to really understand what is the difference between these two. The third one is about the preventive action. Okay. So now just I'll ask a question to you. So I would like to know from you, like whether all these three terms are same or they are different. So if they are different, then what is the difference? Maybe you can raise your hand and then I will ask somebody, particular person to just answer the question. So correction or containment or defect repair, corrective action, preventive action. So whether these three terminologies, whether they are the same or they are different. So if they are different, then what is the difference? Yeah, Mr. Sinha, answer Sinha.
Yeah, sir. The first thing is something like all of them are dependent on if the action has been taken, or what are the things that we have to take. Things that are a corrective action if the issue occurs. Like the correction is something like a occurrence of any incident. Suppose there is something like a.
I think there is some echo is coming.
Yeah.
I think there is some echo
So
is coming.
voice is double voice coming.
Yeah. Just you can just put it on mute.
Yeah.
Just you can just put it on mute. Yeah. Okay, Rahul, can you explain? Yeah. Okay, Rahul, can you explain?
So the action taken on the root cause to prevent recurrence, that is called correction.
Action taken on?
And
what is correction?
Action taken on the
What is correction?
action taken on the root cause to prevent recurrence, that is called corrective action. And action taken on the potential causes of failure, potential causes of failure, that is called preventive action to prevent occurrence.
Okay. Okay. So I'll just maybe what Rahul said, I'll just add to that. You are hearing any echo now from my side? You are hearing any echo now from my side?
Yeah, we are hearing.
Yes, sir.
Yeah, we are hearing it.
Okay. So I think if I'm putting you all on mute, then I think we're not. So I think
still echo occurs.
Okay, is it clear now? It's okay. Yeah, I think there is some problem if somebody is speaking. So maybe till the break, then I will just see whether I can continue with that, and then maybe we'll just see after the break. Okay. Now it is okay, right? You can just confirm whether it's okay by typing
okay.
yes.
It's okay.
Okay. So correction is actually action you are taking on the product to ensure that the problem is solved, right? So action taken on the product. To address the issue. So for example, now again, I am taking the example you have of the rod. So you are supplying some 10 millimeter rod to the customer, and then the customer is saying that some rods are above the specification. Then you just sort out all the rods by using a gauge or by using a vernier caliper. And then whatever is coming more than the specification, then you are doing the regrinding. So that we call that as a defective pair, right? And then corrective action is action taken on the process. So to avoid recurrence of the problem. So that means you are finding that the dimension is more. So immediately correction what you have taken, correction or the containment action what you have taken is you are just sorting out whatever is above the specification, and then you are doing the rework on that. Then that is a correction. So any action taken on the product to correct it so that that can be made usable. So that is a correction. So once that emergency situation is over, then again you just try to find out what is the root cause of the problem, why the process is producing the above specification product. Then whenever you are analyzing the root causes, you are finding that there is an excessive tool wear out is there. So because of the tool wear out, the dimension is coming more. So then you just go and adjust the settings in the tool so that you are giving more depth of cut to the parts, so that now the parts are coming okay, right? So that means you are taking some action on the process so that the problem does not occur. So that is the corrective action. Preventive action is action taken on the process. Action taken on the process to avoid occurrence of the problem. So that means the problem has not happened so far, but again, even before the problem happens, we are taking some action so that the problem does not occur at all. So that is the difference between correction, corrective action, and preventive action.
Corrective action, could you please repeat?
Corrective action is action taken on the, that means the problem has already happened. So after the problem has happened, then again, we are trying to analyze what is the root cause of the problem. And then we are taking some actions so that the problem does not occur again, it does not come again. That is the corrective action. Preventive action is the problem has not at all happened, but anticipating that the problem may come, we are taking some proactive action so that the problem does not occur at all. So that is the preventive action. I will just give a very simple practical example on this thing. So for example, so assume that in your home, your spouse and your kids are two kids are there. So suddenly you find that your son is getting affected by malaria. Then you take him to the doctor, and then the doctor will give an injection, and then he will give a medicine to them. So that means that is the action taken on the product so that the problem can be solved. So he has to do something immediately so that the fever is addressed, right? So that means that giving the injection and giving the tablets, that is a correction or the containment action. Then once you come home, you do not want anybody else from your home to be affected by malaria. So again, you just look around your house. What are the possible reasons why malaria has been, your son has been affected by malaria? Then you are finding that near your house, some stagnant water is there. So because that, again, a lot of mosquitoes are there. Then again, you are getting some arranging for some insecticides to be sprayed on those stagnant water so that mosquitoes can be killed. That is the one action you are taking. And the second action, you are finding that your doors and windows are not having any mosquito nets so that the mosquitoes are coming inside so that again, that is also a problem. Then you are immediately arranging for the mosquito nets to be put in all your windows and doors, right? So that the mosquitoes do not come at all. So that means the problem has already occurred. So that means your son has already been affected at your home because of, by malaria. But again, you don't want the problem to recur. So again, you are taking some action. So that is the corrective action. Preventive action is right now, nobody in your house has been affected by malaria, but you are hearing that in your locality, many people are getting affected by malaria. And then you are just proactively analyzing. Then if you want to prevent malaria to come into your house, then what are the actions you can take? Then you are finding that you will have to spray the insecticide on the stagnant water and you will have to put in the net. So even before somebody is getting affected in your home by malaria, you are taking this action. Then we call that as a preventive action, right? So correction or containment is immediate action you are taking on the product so that the problem is immediately addressed, so that the product is becoming usable, so that the production can continue. That is the correction or containment. Corrective action is you are taking some action so that the problem does not repeat. Preventive action is even before the problem is coming, then you are taking some action so that the problem does not occur at all. Okay. So now I think these are the 8 steps we are doing. So let us now see the steps one by one. So the first one is identify the team. That is the first step. Once you have identified the team, you will have to define the problem. So what is the extent of problem? What is the problem? Where the problem is coming? What is the extent of the problem? So all those things we'll have to quantify the problem so that the problem is clearly defined, right? So that is again very important. Then you will have to go for the corrective action or the containment action. So what are the actions you will have to take immediately so that in a short term the problem can be solved. Then you'll have to do the root cause analysis to find out what are the root causes for the problem. Then once the root causes have been identified, then you'll have to again brainstorm and then find what are the long-term corrective actions you can take. Then you implement and verify those. Then if those corrective actions are effective, then how that can be communicated to the other machines or the other branches or other locations so that they can implement those actions even before the problem occurs in their place, and then congratulate the team and close the particular problem. So these are the 8 steps. So again, you can see that these 8 steps follow a PDCA cycle. That is a plan, do, check, and act. So I think you are aware about this. We also call this a Deming wheel or a Deming cycle. So that means whenever we want to make some improvement, so we will have to plan for the improvement. Then once we plan it, then we just implement the plan. And then after implementing, we will have to check whether we are getting the improvement, whatever we have planned. If there is a gap, again, we'll have to analyze what else we can do and take some action. So if you do this, again, we find that some small improvement is there. And then again, you continue going on doing it so that we are getting a continuous improvement. So out of the 8 steps, whatever we are taking as a part of the 8D, so we find that forming the team and the describing the problem. So that is the plan part of it. Then taking the containment action and doing the root cause analysis. So that is the do part of it. Then implementing the corrective actions and tracking the effectiveness and validating the corrective action. That is a check part of it. And then after the validation, again, further improvement, whatever we are taking, and finally closing, that is the action part of it, act part of it. So again, you can find that the 8D follows the PDCA cycle. Okay, so let us start these activities one by one. What are the actions we have to take? The first one is forming the team. So you'll have to select the team members. So the team members with the appropriate skills are nominated based on the problem description. So depending upon the skills of the people who will be able to contribute for quantifying the problem or analyzing the root causes for the problem, or who will be able to give the solution for the problem, or who will be able to check whether the corrective actions have been properly implemented or not, right? So again, taking all this into consideration, we'll have to select the appropriate team members. So normally it will be a cross-functional team. So don't take the team members from the same department. So you'll have to be a cross-functional team. So people from different departments, they'll have to be included in the problem-solving team. Then you confirm the team structure and assign the responsibilities among the team members. So depending upon their role within the organization, then you'll have to give in this particular 8D format. So what is their role? Maybe somebody may be designated for collecting the data. Somebody may be designated for identifying the root cause of the problem. Somebody may be designated assigned for implementing the solutions like that. So what is the role and roles and responsibility for each and every one of the members? So that is to be determined. So select the members, then form a cross-functional team, and then assign the roles and responsibilities. So that is a step 1. In step 2, again, review the problem or improvement opportunity, identify the team leader and members, and establish the team. So the ideal team size will be around 3 to 7 people. So if the team size is going to be less than 3, then the creativity, because again, as you are rightly saying, we will be doing a lot of brainstorming session in order to identify the root causes and solve the problem. If you are having lesser number of people, then the creativity will not be there in the team. And then there will be a shortage of ideas, and then you will not be able to come out with the effective analysis of the root cause or effective solution. So that is why less than 3 members is not advisable. At the same time, more than 7 members is also not advisable, because again, the team size is very large, and then managing that particular team may become a problematic area. So ideal team size can be from 3 to 7. Then once you have identified the form the team, the second one is the define the problem and its effects. So you have to really define what is the problem and what are the effects it is having. So you have to really define the problem. So the different tools what you can use are 5W 2H. That is a 5W, right? What, where, when, who, where. So this 5W and 2H, how and how much. So you try to answer all those questions, then you'll be able to define the problem clearly. And the second one is about is not matrix. So what, like again, we are going to ask all these questions in the format. So what is the problem and what is not the problem? Where is the problem and where is not the problem? So again, I'm going to explain what is that is not tool. So using that particular matrix, again, we'll be able to identify, quantify the problem and define the problem. Then again, we are going to learn about the other 2 tools, Pareto chart and check sheets. So using these tools or a combination of these tools, then you will be able to clearly define what is the problem you are having on hand. Finally, the target is to come out with a precise description of the problem what you want to solve. So first, let us start with what is a Pareto diagram. And so Pareto chart is actually a specialized form of graphs to identify a critical cause of a problem. So that means Pareto chart is really used in order to prioritize what is the problem to be solved. So prioritize the problem to be solved. So this Pareto word is derived from one Wilfredo Pareto. So he was an Italian economist. So he was doing a research on how the wealth of Italy was distributed among Italians. And then he found that 80% of the Italy's wealth, 80% of Italy's wealth was distributed among 20% of Italians. So he found that there is a lot of disparity was there, and 80% of Italy's wealth was distributed only among 20% of Italians. And then this concept was again Ishikawa, who was a Japanese quality guru. Then he told that this particular problem concept can be used for problem solving. And then he told that 80% of the impact of the problem are caused by 20% of the causes. He told that 80% of the impact of the problem are caused by 20% of the causes. And then this can be used for problem solving. So I will just give an example in the next slide and then explain how the Pareto chart can be used. So for example, you assume that you are working in an IT service company of maybe around 4,000 employees are there. So in order to take care of your hardware, software, and internet related issues, you are having a tool wherein whenever you are having some problem, then you can just log into the tool and then you can just raise a ticket in the tool. So this ticket again will go to a IT support team. and then they will just analyze what is the problem, and then they will just give the solution for the problem. And then once the problem is solved, then the ticket can be closed. So currently there are around 20 people are there in the IT support team. And then the management feels that 20 people is too high a number, and then they want to reduce it to 10 people. So then if you want to reduce the number of headphones in the IT support team, then accordingly you will have to reduce the number of tickets. So then this was taken up as a improvement project. And then the improvement team, then they collected the data on what are the different possible reasons for this, because their objective was to reduce the number of tickets. And then in the system, again, the tickets can be raised because of any 20 different causes are there. So there is a drop down in the tool. So out of these 20 different causes, for any of the causes, you can raise the ticket. So now the team, again, for a particular month, around 1,000 tickets were being raised, average. And then they just wanted to collect what is the defect type, right? For what type of defects, how many tickets are raised. And then they found that mouse related issues, 416 related tickets were raised, keyboard issues 221, unable to install software, like that 92 tickets were raised. So you can find that the top 3 causes, right? The mouse issues, keyboard issues, and unable to install software, this itself was contributing to more than 85% of the problem. So the 80-20 rule says that the 80% of the impact of the problems. So that means 80% of the total impact of the problem is 1,000 tickets. So 80% of 1,000 tickets. So that is equal to 800 tickets. 80% of the problems are caused by 20% of the causes. So that means 20% of 20. That is the total 20 is there. So 20% of 20 causes. So that is equal to 4 causes. So that means 4 causes out of these 20 causes, 4 causes are resulting in 800 tickets. And if you are going to focus only on these 4 causes, then 80% of the problem will be solved. So the Pareto chart will help you to really quantify the problem, and then you will be able to identify what is the potential causes, what is the where you can just focus. So this Pareto chart is now used for defining the problem in your this thing. Whenever you are having the problem, so you can just take the count of maybe whenever you are producing, then the customer is talking about a particular problem. Then you can just collect the data, and then try to plot a Pareto chart, and then try to find out whether the type of problems whatever is coming is same as whatever the customer is saying. So the Pareto chart is really useful for quantifying the problem and describing it very correctly. The second tool, whatever you can use for defining the problem is not. So that means like who, again, you can just address the 5 questions: who, what, where, when, why, and how. So that means who is affected by who reported the problem and who did not report the problem. Then who is affected by the problem and who is not affected by the problem. Yes, Sina, any questions?
Yes, sir. So there is any difference between Pareto chart and Pareto analysis?
Yeah, both are same only. You can say that Pareto chart or Pareto diagram or Pareto analysis all are same only.
Okay.
Yeah.
Okay, thank you, sir.
So is not is like you have to say like who reported the problem and who did not report the problem. Say for example, you are now producing a particular batch of material, and you have sent it to 2 different customers, and then only one customer A is reporting that there is a problem, but again for the same batch of the material, the customer B is not reporting the problem. Then you can say that who reported the problem. That means customer A has reported the problem, and then customer B did not report the problem. Then it is becoming very clear, right? That means it is not a universal problem. It is a problem to one person, one customer, but again, it is not a problem to the other customer. Then who is affected by the problem, who is not affected by the problem. Then what is the problem, then what is not the problem. So for all these questions you ask, who is reported the problem, who did not, then what is the problem, what is not the problem. Maybe the customer is talking about the crack, then what is the problem, then the components or the items are having cracks. So what is not the problem? The items are not having any chipping off or any contamination or any other part. So you are very clear about what is the problem and what is not the problem. Where is the problem? So the problem is only on the exterior surface of the item. Where is not the problem? The problem is not there in the interior parts or on the bottom or the top. It is only on the exterior part. So whenever you are going to address where is and where is not, then you will be able to clearly define the particular problem, right? So you try to answer all these questions: who, what, where, when, why, and how, is and is not. Then you will be able to get a clear identification about the definition about the problem. So again, this is one example. So for example, what is the problem? I am having the problem in remote access is running slowly. So that means whenever I'm trying to access my system by a remote, then I'm finding that it is running very slowly. So what is not? What is not a problem? Local access. So that means if somebody is trying to access from locally, whenever I'm trying to access my machine local, then it is not a problem. So what is the difference between these two processes? Then use of WAN, right? So where is the problem? So when the remote access is tried from Germany, then that is a problem. But again, if it is not, if it is access being done from other countries, then that is not a problem. Then what is the difference between the access from Germany and from other countries? Maybe the different WAN links and routers are there. For Germany, different links and routers are there when compared to the other countries. Then when is the problem? So the problem is all the time. So the problem is not at a particular time or days, it is always present. And then again, when the problem is that since 20th of January, the problem is that before 20th of January, the problem was not there. Then what is the extent of the problem? All transactions take about twice the normal time. So that means more than twice normal time. Again, that is also not a problem, and complete failure is not a problem. So by addressing these questions, then you are able to clearly pinpoint what is exactly the problem. So you are able to find that the problem is only happening whenever the system is being accessed on a remote from the remote place. And then that too, when it is being accessed only from Germany, not from other countries. And then this particular problem is happening all the time, not during a particular time or a particular days of the time. It is always happening. And then it's happening only from 20th of January. It was not happening before that. And then the extent of problem is that it is almost taking twice the normal time. So it is not neither taking more than twice the time or there is a complete failure. So by doing this particular analysis, you'll be able to clearly define what is the exact problem. Then again, check sheets again is again a tool. Again, it's a part of the 7QC tools, which will try to identify like what is the extent of problem we are facing, right? So for example, assume that you are working for a beverage manufacturing company like Coca-Cola. So there again, the empty bottles are coming to an automatic filling machine, then gets filled up, then goes to the next machine where the top cap is put, then goes to the next machine where the label is wrapped, and then goes to a conveyor to the with the quality control, where some random samples will be picked by the quality control person, and then he will again check what type of defects we are getting. So we have already determined what are the different types of defects are there. And then whenever the operator is checking, then he can just put a tally mark whenever he is finding a particular defect type, then he can put a tally mark against that particular defect type. Then maybe at the end of the day, then you can at the end of the shift, then you can just count the number of tally mark and then say that in the particular shift, so a total of 31 defects are found, out of which 5 were bottle broken, 3 were cap loose, like that. Each and every defect type, how many number of defects are found. Then again, if the information is captured for the all the 3 shifts in a day, then all the 6 days in a week, and then all the 31 days in a month, over a period of time, then we will be able to get a consolidated data. And then we will be able to know for each defect type, then how many number of defects are coming. Then again, we can take this data into the character chart and then try to find out of all this, then which defect is coming very frequently, so that we can just take action on that. Right. So the AD report, whatever you are trying to solve, so we can try to focus on the top defect, so that that particular defect can be, we will be able to find out the root cause of that particular defect, and then we will be able to identify that once for all. So the whatever the tools, whatever you have learned now, the Pareto diagram or a Pareto chart or a check sheet or the is not analysis will help you to really identify what is the biggest problem that needs immediate attention to be solved, and then how we can define and how we can quantify the problem. So that is the second step. Defining the problem, that is the second step. Then the third action is to determine the most suitable containment action. So you know you have identified what is the current problem, which is a significant problem is there, and then how we are going to identify the problem and come out with a solution for a short-term solution, short-term corrective action that has to be put in place. The why we are doing is to give a instant support to the customer and implementation of the containment action. As I told you, whenever we talk about the containment, so the customer, it can be an internal customer or it can be an external customer, right? So the idea, the why we are taking this containment action is that the customer should not suffer. So if there is a problem is that the customer should not wait till the problem is root cause of the problem is analyzed and a permanent corrective action is taken. So some immediate solution needs to be offered to him so that he can implement that. So containment actions will be taken in order to make the product or service usable immediately. So that is the purpose. So it should often bear no relation to the cause of the problem, because as I told you, whenever we are having the fire, our immediate focus should be on how we are going to ensure that the fire is put out so that it doesn't spread to any other place, and then the impact is not going to be very high. So we need to take some quick action so that the problem is immediately addressed and solved. So that is the containment action. So that does not have anything related to the root cause of the problem. So the cost consideration should play little or no part. So for example, now the customer is complaining that the serious complaint is there, a lot of defective parts are coming. Then at that point of time, don't think about like I have to send somebody by flight. So, and that particular person has to go and stay at the customer place for 10 days. And then all his boarding and lodging expenses I will have to bear. And all those, so everything is put together, it is going to cost some 50,000 rupees to the company. So then maybe can I send a person maybe after a week, and then by train or something like that. And then, so if you're going to look into the cost, then the problem is not going to be solved immediately. The customer is going to face a problem for a longer period of time. And then in that case, that may lead to customer dissatisfaction. And in the end, maybe the order may be cancelled or you may resort to some other serious action. So whenever you are considering the containment action, it has to be immediate, it has to be brought, somebody has to be sent by flight, some 5% has to be sent by flight, then that action has to be taken. Otherwise, that will have a long-term repercussion on the customer. Then this particular containment action must remain in place until permanent solution is implemented. So till you have found out the root cause of the problem, identify the permanent solution for the problem, this containment action has to go on. So for example, you have delivered some defective parts, the customer is complaining that some defective parts has been sent to the customer, and already some 5 lots have been already sent to the customer. Then you immediately send the enough people to the customer place so that they will do the sorting there. And then you just make an analysis about what is the extent of damage in the company. Maybe already some 2 batches are there at the finished goods. So again, you put some persons for doing the sorting out action at the in the finished goods, and then whatever has really so whatever is in the process, again you have to check. So by that time you find out the root cause of the problem and the permanent solution is implemented. So this sorting out action has to be done. 100% sorting has to be done. So that has to be done till the time you are able to put in a permanent solution to the problem, and you are sure that the problem is not going to come back. So till you are putting in a permanent solution in place, this particular containment action should be in place. So the main reason for taking the containment action is so that the customer does not shout, and then you are getting some buying some time so that you will be able to identify the root cause of the problem and you will be able to solve the problem once for all. So this is actually a sort of a process flow chart for implementing the containment process. So that means first decide what is the intermediate containment action, what you are going to do. Then you just try to find out what are the possible containment action you can take, and then they try to choose the best solution. And then by doing that, will the customer be isolated from the defect? If yes, then you can just go to the implement it. If not, again, you will have to again go back and then look for some alternate solution. Then again, once the containment action is implemented, then by doing so, whether the defect is eliminated, yes means you can continue that, no means again you have to go for the different solution. Then again, whether the corrective action is completed. So this action has to be, containment action has to complete, has to be done till the permanent corrective action is completed. So till that time you'll have to continue with that. Okay. The fourth step is the determination of the root causes. So now you have a particular problem was reported, then immediately you formed a team to solve the particular problem. Then you just define the problem, quantify the problem. You are able to get that definition and the extent of the problem. Then you just decided upon what is the containment action to be taken, and then you are taken action to implement the containment action. Then now you have bought some enough time so that now that heat of the moment, so I think the temperature has come down. So now is the time for you to find out what is the real root cause of the problem. So again, for identifying the potential root causes of the problem, you can use the tools like the flow chart or the cause and effect diagram or a fishbone diagram, 5W, 5Y analysis like that. So these are all some of the tools you can use for identifying the root cause of the problem. And finally, the objective of this particular step is to confirm the real root cause of the problem, potential root cause of the problem. So the different techniques or the tools that you can use, or you can use the brainstorming technique and the fishbone diagram for identifying all the potential root causes. And then you can also use the 5Y analysis for finding out the root cause of the problem. So again, the example for a 5Y analysis is given here. So the problem is the vehicle is not starting. So you are just every day you go to our office by a two-wheeler, and then yesterday when you really wanted to start, the vehicle was not starting. So you wanted to analyze what was the problem. So why the vehicle is not getting started? Then you find out that the battery is dead. Why the battery is dead? Because the alternator is not functioning. Why it is not functioning? Because the belt is broken. Why the belt is broken? Because the belt has served for more than the life. Why it has served for more than life? Because it was not maintained according to the recommended service schedule. So that means the vehicle you are supposed to give maximum of maybe 6 months or 5,000 kilometers of running, you should have given for the regular service. But now we have exceeded that particular time. Maybe for the last 1 year, you have not given it for service. So because of that, the belt has overlived its life. So because of it, it has gone weak and it has broken. Right. So the problem was the vehicle was not starting. And when you ask why 5 times, then you are able to find out the root cause of the problem. Then you will be able to take action on that. So even though we call it as a 5Y analysis, it is not necessary that every time you will have to ask exactly 5 questions, 5 whys. Sometimes maybe by asking the 3 times why, you will be able to find out the root cause of the problem. Sometimes you may go to some 7 or 8 steps in order to go to get to the root cause of the problem. So one other example I can just give you, like for example, yesterday, like I was late to the office, right? So there was a problem. Why was I late? Then I just there was a delay in filling the petrol. So why there was a delay in filling the petrol? Because I did not get I forgot to take my debit card, or I didn't have the money. So why you forgot to take the debit card with you? Because I started late from home. Why did you start late from home? Because I got up late. Why did you get up late? Because my alarm did not ring. Why your alarm did not ring? A spring was broken. So that means the problem was that I went late to the office. That was the problem. And again, when you asked why multiple times, then you are able to find that the alarm, the spring and the alarm breaking, that was the root cause of the problem. So asking this why multiple times, you will be able to get the root cause of the problem. Then again, this fishbone diagram. So we can also call that as Ishikawa diagram, because all these names are same, Ishikawa diagram. We can also call that as the cause and effect. And we can also call this a 4M, 5M or 6M analysis. Actually, it started off with 4M. We initially started with only with machines, method, materials, and manpower or personnel. So we started off with only 4M. Then measurement was taken up as a 5th M, and then mother nature or environment or mother nature. So this personnel is actually manpower, and environment is mother nature. So initially we started off with only 4M, machines, methods, materials, and manpower. Then 5th one was added as measurement, and now we are currently doing the 6M analysis, that is mother nature. So that means whatever the problem you want to, for which you want to find out the root causes. So the effect or the problem, you just put it at the head of the fish. So here we want to find out what are the problems for a bird burgers that have been cooked. So what are the problems? So the problem, whatever you are facing, you just put it on the head of the fish, and then try to find out what are the material related issue, what are the method related issue, and then what is the machine related issue, then what is the mother nature, measurements, and the manpower related issue, right? So normally what happens is you just try to identify the root causes, and then say, for example, now the recipe is a method related issue. And then if you want to again find out what is the problem with the recipe, again, the recipe is either the recipe was flat, that was originally that was not correct, or the second thing is it is not followed. The original recipe was given correct, but that was not followed properly, right? So the first categorization comes because of either any one of these 6 reasons. That is the first categorization. Then the second categorization, whenever you are finding that this is the problem, again you want to drill down to the next level, then again you can drill it to the next level. And then again, why it is not followed, maybe again you can just go to the next level. Maybe the instruction was in English, the language was not understood or something like that. So why it is not followed means language not known, right? So till you are able to find the root causes, you can go to multiple layers. So the fishbone diagram or the cause and effect diagram will help you to find out the root cause of the problem. So you can use either the 5-way analysis or the fishbone diagram in order to find out the root cause of the problem. So once you have identified the root cause of the problem, then the next action will be to take the corrective action. So what are the actions you can take in the process so that you'll be able to rectify the problem? So provide alternative solutions to the problem and verify that the problem causes are eliminated without introducing new problems. So whenever you are trying to find out a solution, again do a brainstorming session, try to generate as many solutions as possible. And then from these solutions, you try to pick up what is the best solution that can be implemented. So that is what is the 5th step, that is the determining what are the corrective action. So the output, final output of this particular process will be the approval and application of the corrective measures. So what are the actions that should be taken? So that will be the output from this particular step. Okay, so identify and select the best possible permanent corrective actions that will address the and correct the root cause. So whenever you are implementing the or designing upon a particular action, you should also ensure that by implementing this action, you are not ending up with a new this thing. Some other problems should not happen, right? So you have to ensure that by implementing this solution, no new problems are being created. So whenever you are trying to select a particular solution, then you have to objectively evaluate against the predetermined decision criteria. So you'll have to see that whenever you are, say, for example, a particular root cause is there, then 5 possible solutions are there. Then out of these 5 possible solutions, which solution you are going to implement. So again, there are some tools which are available. So we are going to learn about that. So from the different possible solutions, how to select the best solution. So that needs to be done at this particular step. Then once you have determined that, then document and verify the permanent corrective action. So it is very important to verify that the solutions will eliminate the problem. And then review should happen before implementation of the corrective action. So the tool which is going to be used for determining which is the best solution, we call this a PU matrix, PU matrix. So this is a criteria-based decision matrix, which uses the criteria scoring to determine which of the several potential solutions are to be selected. So after the root causes have been determined, then whenever you are doing the brainstorming session, in order to solve a particular root cause, then you may be coming out with multiple solutions. So from this multiple solutions, how are you going to determine which is the best solution? Then you will be using this particular tool. So again, this I will just explain you how you do that. So for the Pew matrix, what you have to do is first you have to determine what is the criteria. What are the criteria based on which you are going to select the best solution. So maybe for a particular problem, how far this particular solution is very effective. So that can be one of the criteria. Then availability of resources for implementing the solution. So that can be a criteria. Support from the senior management. Then the long-term benefit by implementing the solution. Then the time taken to implement the solution, ease of implementation, cost of implementation. Okay, these are all some of the criteria based on which I'm planning to select the solution. Then once I have listed down all the criteria based on which I'm going to take the decision, then I have to give a importance rating. How far, according to me, which criteria is very important. So for that, again, I will have to give a scale of 1 to 5. So whatever the criteria I feel that is very important, then I will give a rating of 5. And then whatever is not so important, then I will give the rating of 1. So for each of the criteria, I will give a rating of 1 to 5, depending upon the importance. Then once it is there, whatever the current process is there, then I will just give a 0 rating for that. And then whatever the alternative solutions are there, alternative 1, 2, 3. So for that, I will just give a, and then I will, for each of the criteria, then I will compare with the current process, whether the alternative, whenever I implement the current alternative solution 1. So whether that will improve the process, then I give a rating of 1. If that particular criteria is not at all going to be affected, then I will give a rating of 0. And if implementing the solution is going to negatively impact the particular criteria, then I will give a rating of -1. So the performance rating, I will give a rating of -1. If it is going to result in a negative impact, is going to be there. If no impact is going to be there, then I'll give a rating of 0. If it is going to be a improvement is going to be there, then I'll give a rating of 1. So for each of these criteria, for this particular solution, I give a rating of -1, 0, or 1. Same way for alternative 2, alternative 3, alternative 4, I will give a performance rating. Then in order to get at the final rating, what I like to do is I like to multiply the importance rating multiplied by the performance rating. And then I like to add everything. So that means 5 into 1, 5, plus 3 into 0, 0, plus 2 into 0, 0. Then 2 into 1 is 2. So 5 plus 2, 7. Then 4 into -1 is -4. So 7 minus 4 is 3. Then 1 into 0 is 0. Then 5 into -1 is -5. So 3 minus 5, -2. So that means the net score is -2. So that means if I'm going to implement alternative 1, then the current process itself is going to be deteriorated. So no improvement is going to be there. So in that case, this solution is not effective. So I will not go for this particular solution. But if I am considering the second solution alternative, then my net score is 5. So that means that is going to improve my current process, right? Then in that case, I can go for I can like that. If I have some 5 or 6 alternative solutions for that, then I get the net rate scoring for each of these alternative solution, and whichever is getting the best solution, then I will have that as a solution, right? So a Pooh matrix will help you to identify the best possible solutions for the different alternatives. Okay. So any doubt in whatever you have covered so far up to step 4 or 5? Any doubts?
That the Pooh matrix, what you are, it's something like it's a manual or a document in the form of manual document, just like a sheet we have to implement or mark it.
Yeah, you just it is only a small template, right? You just prepare a small template like this. So you just list down what are the criteria you are going to use for evaluating the solution, and then you can use this simple template. Okay. Okay. So now the sixth step is to you are now decided upon which corrective action you are going to take. Then you will have to verify whether the how you are going to implement it, right? Establish plan to introduce the corrective action. So you'll have to develop the implementation action plan. So that means what are the actions you are going to take? So who is responsible for implementing it? When you are going to implement it, and any support is needed for that. And the output from this particular process will be the implementation of the corrective action. So that means whatever the actions you have decided, now you'll have to implement those permanent corrective actions. So that is step number 7. So that means implement the best permanent corrective action and ensure effective monitoring of the implemented action. So that means you are saying that, say, for example, now you are analyzed that the root cause of the problem was the temperature was very high. That was the root cause of the problem. Then you are saying that the temperature has to be maintained at 100 degrees centigrade. So that is the action you have taken. And then you implement and set the temperature at 100 degrees centigrade. And then you monitor on a regular basis whether the temperature is maintained at 100 degrees centigrade, right? So effective monitoring of the implemented action. So detect any undesirable side effects of implemented corrective action. So whenever you have implemented the corrective action, again, you closely monitor the particular process and then see whether any negative effects are there. Maybe that particular problem or that particular defect has been reduced or that has been eliminated. But by changing that particular parameter, maybe some other problem has come. Again, that is also not reducible. So you'll have to really look for whether the particular action has been implemented correctly. You will have to closely monitor that. And then whether the implementation of the particular action, whether that has led to some other problem, that also you'll have to monitor that. So if the problem is still existing, then you have to fine tune your actions or reanalyze the problem to identify the new root cause. Suppose you are finding that maybe the changes whatever you have made is not effective, then you have to see, reanalyze, and then see what else you can do. So finally, you have to verify that the corrective actions taken are efficiently by using the real data from the process. Then once you have implemented the corrective action and you have monitored and you have ensured that the permanent corrective action is very effective, then you can go for the preventive action. So preventive action means now whatever the improvement you have done, you will have to now document it, and then you will have to, like say for example, now you are finding that the temperature has to be maintained at 100 degrees centigrade. So that is the solution. So that has solved the problem in a particular machine. Then you will have to revise your document so that you will have to now ensure that this temperature has to be maintained at 100 degrees centigrade, and then the temperature has to be monitored every hour, and if any deviations are there, that will be rectified. So all those things have to be documented. And then now that you have implemented in one particular machine, then the same action you can take it for the other machines also. And then if you are having the different your operating manufacturing site is there in different location, they again you can send the document to the other locations also, so that they can implement this particular solution. That's what we got as a preventive action, so that in other machines or in other locations, even before the problem can occur, they have the solution in hand. So modify the equipment or materials or the process procedures or management system to prevent the related solutions from occurring, problems from occurring. So that means whatever the problems you have faced and whatever the solutions you have implemented, we just make a proper documentation and share it with the relevant people, so that they can also implement the solution before they come across this particular problem in their areas. So ensure the horizontal deployment of corrective action. So that means if there are 8 machines are there and you have identified the problem in one machine and you have taken action in the first machine, then ensure that the same action is implemented in the other 7 machines. So that's what we call that as a horizontal deployment. Then update the systems, document, processes, and procedures to prevent the recurrence. So sustain the gains from the current improvement and update the procedure, documentation, training, etc. And then share the learning to the other departments or the other locations where there is a possibility that similar problems can happen. Then the last one is about the congratulate the team and conclusion. So that means you'll have to conduct some sort of a final meeting of the AD team. So once you have a particular template in which you will document all these findings, whatever this happenings, whatever has happened there. And then in that meeting, again, you'll have to recognize all the contributions of the team members and develop a climate for ongoing improvement. Why it is very important is that, so there was a problem which was very serious, maybe a customer complaint or a major non-conformance in your product. So that was a problem that needed immediate attention. Then your team was formed, and then you did a systematic approach in order to solve the problem. And then at the end, you were able to come to a solution, and then it was found to be effective. And then not only in your particular machine, in the other machines and the other locations also, you were able to successfully avoid future problems. So in that case, again, you will have to again give the recognition, recognize the people's effort, so that this will motivate them to get involved in similar exercise in the future. So, for example, if they have been a part of the team, and then the particular problem was solved, but again, after the problem was solved, then the success of the particular effort, or it was not recognized by the management or the customer or something like that, then again, the next time they do not have any motivation to get involved in such effort, because they say that, okay, even if I'm going to work on that, then nobody is really going to recognize me for that, then why should I get involved in that? So in order to avoid that type of attitude, then you have to ensure that the contribution from the each and every team members are recognized during the meeting. And then finally, you will have to close that particular AT report. Formally, you will have to close the AT report and then send it to the customer and to the relevant people. Okay. So again, this actually is one of the example we can just give. So here, yeah, organization received customer complaint about shrinkage on an automobile part. So again, the management demanded a thorough analysis based on the 8D problem solving report. Right? So that means the company was making some automobile components, and then they received a customer complaint about shrinkage on a particular sum. Then you have to see how that can be addressed. So first one, D1 is a team was created with the purchase team and the team leader and the manager. Then we define the problem. So what is the problem? Complaint, shrinkage on sum. When was it seen? It was observed in the last batch. Why did it happen? Due to a defect in the entrance area. Who reported? How much of the production is affected? So what is the extent of the problem, right? So you'll have to really define the particular problem. That is the second step. Then the third team is about the containment, like what are the actions you can immediately take. So the decision is taken to stop the consignments, right? So that means whatever has been delivered to the customer, then you send some people so that they can go there and then sort out, segregate that particular defective parts at the customer place. And then whatever the batches which are ready for the dispatch, again, you stop delivering that particular this thing. So you unpack all those items, and then again, you do the segregation at your place and segregate only the good parts and send it. So that means whatever has been delivered to the customer, that needs to be sorted out, and whatever is ready for dispatch, that also needs to be sorted out, so that the problem does not happen. So again, this is the containment, immediate action is to take, so that the customer's production or his operations are not affected. Then the fourth step is to identify what are the root causes of the problem. So again, you just ask the 5 why analysis. So why was the shrinkage low? There was a shrinkage at the in-gate area. Why there was a shrinkage? Because it was a high pouring temperature. Why was the high pouring temperature was there? Because the pyrometer reading was incorrect. Why the pyrometer reading was incorrect? Because the condition was not checked. Why it was not checked? Because there was a faulty pyrometer, right? So the root cause of the problem was that there was a pyrometer was faulty, and that was the reason why this particular problem was happening. So as a permanent corrective action, periodic checking of the pyrometer is suggested to the maintenance supervisor. So that means till now, the condition of the pyrometer was not checked. And then as a part of the corrective action, we say that every day or every week, or depending upon the frequency, then the SOP, that is the standard operation procedure, was maintenance manual. Maintenance procedure was changed so that this checking of the pyrometer, the condition of the pyrometer was included as a part of the maintenance process. Then the permanent corrective action is implemented, and the pyrometers are scheduled for weekly checkup. That means every week somebody has to yearly check whether that is really correct. Then the periodic checking and proper maintenance. So this is the preventive action that is being taken in other places also, so that the problem will not occur. And then finally, the team effort is recognized. So the manager and the team are praised for solving the problem. So again, this is a simple problem, that a simple example of how this can be applied. So again, this is again one of the other example we can take. And again, you have a template. You can see this is a Word document. So this again, you can again download this particular Word document and then you can use this as a template. Either you can use this particular format. This seems to be quite elaborate, the case study too. But this one, maybe it is not there in your PPT. I will ask Riaz to send it again. This seems to be a very simple document, maybe a one-page document. So whenever you are having any non-conforming product in your process, or whenever you are receiving some customer complaint regarding some parts not meeting the specification, then you can use this as a AT report. This format you can use it. This format seems to be quite simple, and you can immediately use it in your process, right? And I will just show you the other Word document also. So you can see that this is a template that you can use it for. So again, zeroth stage is the planning stage. So planning stage means at that particular this point you will have to determine whether really AD problem solving technique is really needed. So that is needed whenever you do not know the root cause of the problem, and whenever you want a detailed analysis, then only you will should be using it. Then the first one is about establishing the team, and then the second one is the problem definition. Then maybe you can just try to make some drawings, or you just take some photographs in order to really explain to the people about what is the problem, right? In order to visualize the problem, then you can just take the photographs or draw some sketches. Then you can do the EC SNOT or the Pareto chart or any other this thing analysis to define the problem. So then the final problem description is written here. So this is the problem description. And then again, what is the containment action? That is immediate action that will be taken. So repair the parts in the inventory, in stock, at the supply station process, and in shipping. So everywhere repair parts are customer. So everywhere, wherever the parts are there, then you'll have to do the repairing. So that is the containment action. Then identifying and verifying the root causes. So cause and effect diagram. So you can just do all those things. And then we find in the solutions. So identify the permanent corrective actions, then implementing and validating the permanent corrective actions, and then what are the preventive actions you are taking. And then you can also say what is the, in the closing stage, you can also write what was the problem before. So you already quantified the problem before the problem was solved, and after the problem was solved, what is the condition, so that you'll be able to clearly tell that yes, real improvement is there. So here they are given that before the problem was solved, this was the sales figure. So after the problem was solved, then you can find that the sales figure has gone up because the problem has been really solved, right? And then finally, the last step about the recognition. So this template you can just again download and then you can start implementing. So either this one or the previous one, you can just use it for immediate usage at your place. So this is about the
attachment not seen, sir. Sir, in PDF attachment not seen.
Yeah. So I will again this one, and again for the FMEA also, I'm going to give you a Excel template. So both this Word document and the Excel Word template for the AT report and the Excel template for the FMEA, I will ask Riaz to send it by tomorrow. Okay. I will.
Okay, sir, no.
He will just put it in the WhatsApp group. Okay.
Okay, sir. Okay.
Any doubt or clarification needed in whatever you covered so far in the 8D? So whenever you are finding that some of the parts or some of the services are not meeting the requirement, then you can use this particular AD report, so that you can just decide upon, quantify the problem, form the team, quantify the problem, then look for the immediate containment action, then look for the root causes for the problem, then look for a permanent solution, implement and measure the effectiveness. If it is effective, then document it, share it with the other team so that they can take the preventive action, and then recognize the team effort. So these are the different steps. So how long does it take to perform AT report? Yeah, that is a good question. So again, depending upon the nature of the problem. So again, it should not take more than a week. So once the problem is reported, so the definition of the problem can take a day or two. Then deciding upon the containment action, and then implementing the containment action again will take a day or two. Then identification of the root causes of the problem again will take a day or two, and then implementing the solution. But only thing is, up to the stage 5, that is the implementing the permanent corrective action, maybe you will be able to complete within a week. Then you wait for a month or so in order to see whether the permanent corrective action is effective or not, right? And then after 1 month, ensuring that the permanent corrective action is effective, then you can go for the preventive action, and then formal closure can happen maybe within 6 weeks or 8 weeks from the time it was initiated. So the main improvement or the permanent solution implementation will take around 1 week. Then you observe it for 4 to 6 weeks, and then after that you can formally close the report.